Right, well, binary is my friend. It really is, or it should be yours anyway, if you want to try and understand IP addressing and subnetting and the like. So we're going to start off with, where do IP address classes come from? So the IP address classes are technically deprecated, meaning we shouldn't really use them, but they're very, very handy to allow us to understand where these decimal numbers came from. So we'll start off writing down the classes, and we have class A addresses, and they basically range from 0 up to, well, actually 127, but we'll find out in a moment that's to 126, 127 technically, and then class B, which starts at 128 and goes up to 191. Then we have class C, and these go from 192 to 223, and then class D, which goes from 224 to 239. Now, these are decimal values, and basically they don't make an awful lot of sense from the decimal. However, if you use binary, they will actually make an awful lot of sense. So what I'm going to do across the top of the page, and this is something you can easily do yourself, is I'm basically going to write out the decimal values for one octet. So we have 128, 64, 32, 16, 8, 4, 2, and 1. That's one octet. Now, our first 0 bit is basically how our routers decide where a network starts. And unfortunately, in the early days, routers were pretty dumb. So they weren't able to do anything like the task that they can do now. So we start off, and I'm going to do 2 lines here with zeros. So our first 0 bit is turned in the first octet of our 32-bit binary address. Now, our first network address we've got is 0. So how do we get that? Well, this top line here is essentially all zeros. So if we fill those in, there's our first value. Our last value is, well, it's technically 126, but as we'll see, it's actually 127. If we put in the 1 bits, 64 plus 32 is 96, plus 16, 112, plus 8, 120, plus 4, 124, plus 2, 126, and plus 1 is 127. So you can now clearly see by looking at the binary where those values come from. Why do we not use 127? Well, hopefully you already know that we use 127 for loopback functionality, 127000, 127001. We basically ping our loopback address. Now that's an A, class A address, so we're actually losing a lot of valuable IP addresses, but that was decided long ago in a time where we didn't really realize how many addresses we're going to need. So that's our class A addresses. Where do our class B addresses come from? Well, essentially our 0 bit moves 1 place to the right. So now we start off and we have 1 0 1 0. And then what's our first network address in class B? Well, actually it's the all zeros network again. So if I just fill in this top line, the other zeros, obviously that's where we get, well, where do we get 128? Well, just have a look. There's our first 1 bit, ties in with 128. So that's where we get our value of 128. Where do we get 191? Essentially, we add in the 1 bits that are left over. And if we add 128 to 32, we get 160, 176 plus 16, 184, 188, 190, and 191. very clear to see there where our class B addresses come from. We carry on the process, and now our 0-bit moves one further place to the right, so we now have 1, 1, 0. And again, our first valid network is the all zeros network, so we just put in those zeros there. And what's our last valid network? We put in all ones. And if we add 128 plus 64 is 192. Plus 16, 198, 208, plus 8, 216, plus 4, 220, plus 2, 222, plus 1, there's our 223. So again, you can clearly see by adding up the binary values, we can see where these seemingly random decimal values come from. So the very last address we use, class D, we use for multicasting. Exactly the same story. Our 0-bit moves one further place to the right. So we put those in. So we start off with 224, and just to do a check, where does 224 come from? 128 plus 64 is 192, plus 32 is 224. First network is the all zeros network, which means we're at 224. And then 239, we add up 8, 4, 2 and 1, add it to 224, and we get 239. So there we have got our classes of address, where they've come from and how they've been worked out. So our subnet mask values are 255.0.0.0. So we're effectively masking off the first octet, the first 8 bits of our 32 bits. Our class B is 255.255.0.0, so that's masking off the first 2 octets or first 16 bits of our 32 bits. And our class C is 255.255.255.0, masking off the first 3 octets. And our class D is 255.255.255.255, and I've got a dog that I need to go and strangle. So that's it for this lesson. We'll move on and find out where our subnet mask values come from in part 2.